What if the greatest journey in human history is actually a one-way trip? Not because we want it to be, but because the universe quietly makes sure of it. We've all heard it before. Humans are going to Mars. It's exciting, it's inspiring, it feels inevitable. But almost no one asks the most dangerous question. What if coming back is the real problem? Because according to the cold, unforgiving laws of physics, returning from Mars might be one of the hardest things humanity has ever attempted. And if there's one person who would force us to face that truth head-on, it would be Richard Feynman. Feynman had a simple philosophy. You can imagine anything you want, but nature will always have the final say. And when it comes to Mars, nature is not on your side. Let's start with the illusion. At first glance, Mars doesn't seem that bad. Its gravity is weaker than Earth's, about 38%. That means launching from Mars should be easier, right? That's what most people think. But this is where reality begins to twist. Because rockets don't just fight gravity, they fight mass. And here's the brutal truth. To leave Mars, you need fuel. To carry that fuel, you need more fuel. And to carry that fuel, you need even more fuel. This endless loop is not a design flaw. It's a fundamental law of physics known as the Tsiolkovsky rocket equation. And it's merciless. Every extra kilogram you add to your rocket doesn't just increase the fuel you need, it multiplies it. This is why rockets look the way they do. Huge tanks of fuel carrying a tiny payload on top. Now imagine trying to solve this problem on another planet. You land on Mars with a limited payload. You can't bring unlimited fuel. It's far too expensive and heavy. So how do you leave? You don't, unless you create fuel on Mars itself. And this is where things go from difficult to terrifying. Scientists are working on a solution called in situ resource utilization. The idea is simple, almost elegant. Mars has a carbon dioxide-rich atmosphere. If you can split that CO2, you can produce oxygen and methane, fuel. In theory, it works beautifully. In reality, everything has to go perfectly. To test this idea, NASA sent a small experiment aboard the Perseverance rover called MOXIE. Its job was to produce oxygen from the Martian atmosphere. And yes, it worked, but only on a tiny scale. Scaling that up to produce tons of fuel, enough to launch a rocket off Mars, is a completely different challenge. You'd need massive systems, reliable power sources, perfect chemical processes. And here's the problem. Mars is not a friendly place to run complex machines. Temperatures drop to minus 60 degrees Celsius, sometimes even lower. Dust storms can cover the entire planet, blocking sunlight for weeks. Fine Martian dust can infiltrate and damage equipment. And unlike Earth, there's no repair team, no supply chain, no second chances. If your fuel production system fails, you're stuck. Not for a few days, not for a few months, forever. But let's say somehow you solve the fuel problem. You build your rocket, you fill it with fuel made on Mars. You're ready to leave. You press the button. Not so fast. Because now you're fighting something even more subtle. Timing. Mars and Earth are constantly moving around the Sun. They only align properly for a return journey every 26 months. This is called a launch window. Miss it, and you wait. On Mars. For over 2 years. with limited supplies, limited oxygen, limited margin for error. And remember, everything has to keep working during that time. Your habitat, your life support systems, your fuel reserves. One failure, and there is no rescue mission coming to save you. This is where Feynman's mindset becomes chillingly relevant. He didn't believe in comforting ideas. He believed in reality. And reality says this: space is not designed for humans. It is hostile, unforgiving, and completely indifferent to whether you survive or not. Now let's go even deeper. Even if you launch successfully from Mars, even if you hit the perfect window, even if everything goes exactly as planned, you still have to survive the journey back. Months in deep space, exposed to radiation from the sun and cosmic rays. Radiation levels far beyond what we experience on Earth. Over time, this radiation damages cells, increases cancer risk, affects the brain, and there's no easy shield against it. Then there's the human factor: isolation, confinement, psychological stress. You're trapped in a metal capsule millions of kilometers away from home with no immediate way out. Small problems become big problems. Big problems become deadly. So when people say we're going to colonize Mars, they're focusing on the dream, not the physics. Because going to Mars is an engineering challenge, but coming back, that's a system of problems stacked on top of each other, each one capable of ending the mission. Fuel, timing, environment, human survival. All of them must work perfectly at the same time. And this is the quiet warning hidden in Feynman's philosophy. The universe doesn't care about your ambition. You don't get points for trying. You only succeed if you obey the laws of nature. Exactly. So, is returning from Mars impossible? Not necessarily. But it's so complex, so fragile, so dependent on perfection, that even a small mistake could turn a mission into a permanent exile. And maybe that's the real truth we don't like to admit. The first humans to step on Mars might not be explorers. They might be pioneers in the oldest sense of the word. People who go forward, knowing that coming back is not guaranteed. Because Mars isn't just another destination, it's a test. A test of whether humanity truly understands the rules of the universe, or is still underestimating them. And if Feynman were here, he'd probably smile and say, "You can't fool nature." And Mars is where we'll find out if we've been fooling ourselves.